Hello kids, I'm Chavi Bansal. Hope you guys know me. So if you see my channel, so far I was putting only zoology related videos, right? And that's why the name of the channel was Chromosome Class. But so many students of mine has requested me to put chemistry videos as well. So what I have done is I've changed the name of the channel to Magic Mentor. And now the channel will have both the videos for zoology as well as for chemistry. Now, coming to the chemistry part, the chemistry is very important subject with the point of viewpoint of Neet as well as J, right? So what we are going to do is we are going to start with the very basic starting so that kids who are in 11th grade can easily go through it, can start understanding from the very start, as well as the kids who are not in 11th grade, 12th grade or repeating batch, they can also go through and clarify their basics. Okay. So, today, we are going to start with the basic introduction to stoichiometry, or in common terms, we call it as mole concept. Fine? Just a second. Yes. So, I hope you guys can see my screen, right? Now, uh, we are going to start with stoichiometry, also called as mole concept. Okay. Now, before we start with the mole concept, there are some certain basic things that you need to understand. You need to know about an atom. Okay. Now, you guys will be like atomic structure, the second chapter, why you're talking about atoms in stoichiometry. But there are certain concepts which are related, and it's better if we start with those concepts in stoichiometry itself. It makes it very easy for us to understand the concepts of mole also. Right. So, an atom. An atom is the basic unit, right? The smallest particle that exists. And it consists of proton, neutron, and electron, right? If I draw the structure, a basic structure of an atom, here the neutron and proton will be present in the nucleus, and outside the nucleus, the surroundings will have electrons, right? This is the very basic way of discussing an atom. Fine. So basically, an atom is made up of neutron, proton, and electrons, right? So when we define an atom of an element, we use certain terminologies. The first terminology is atomic number. This number is equal to number of protons, okay, or number of electrons in neutral state. See, why are we writing this? Try to understand. Protons are positively charged particles. Neutrons are neutral, and electrons are negatively charged particles, right? Now, when we are going to talk about the atomic number, neutral means when the positive charge and the negative charge balances out each other. Means when number of proton is equal to number of electron, the atom is neutral. There is no net charge on it, right? Now, ideally, an atom in its basic state, it is a neutral atom. Fine. So, in that case, whatever the number of protons or the number of electrons will be present will give the atomic number. Fine. For example, atomic number of carbon is 6. So, can I write number of protons in carbon is 6, right? Number of electrons in a neutral carbon atom is also equal to 6. So with the atomic number, we can find out the number of protons or number of electrons, but it is very like we cannot find out the number of neutrons. Okay. So the role of neutron comes in another term called as mass number. Now, what is mass number? Instead of writing a mass number, what can I write is mass of an atom. Okay, means what? See, what happens, we studied here, the atom is made up of protons, neutrons, and electrons, right? So if I have to calculate the mass of one atom of an element, what can I write? Mass of one atom of an element, we can write mass of protons into number of protons, right? Plus mass of a neutron into number of neutrons, right? Plus mass of an electron into number of electron, right? Now, when we are talking about these particles, we are saying that atom is mostly made up of these three particles. If I multiply their mass into the number, I can get the mass of an atom, right? This term is correct. Fine. Can I write it for the carbon atom? Let's see. So carbon atom atomic number is 6, means number of protons is 6, number of electrons is 6, and I'm telling you the number of neutrons in carbon atom is also 6, right? So mass of one carbon atom, can I write it like number of protons multiply mass of proton plus number of neutron multiply mass of neutron plus number of electrons multiply mass of electron, right? Now I can substitute the value. Number of proton is 6 into mass of proton plus number of neutrons is also 6. So 6 into mass of neutron plus number of electrons is also 6. So 6 into mass of electron, right? This is the mass of one carbon atom. Fine. Now let's see what is the mass of a neutron and a proton. Mass of a proton is equal to mass of neutron, which is equal to 1.67 into 10 raised to power minus 24 grams. Okay. Whereas mass of electron is 9.1 into 10 raised to power minus 27 grams, or we can write it as 1 by 1837 into mass of proton. Now, if you see the number we are multiplying with electron is a very small number, right? Even if I multiply it with 6 or 100 also, this number will not add up much to the mass of an atom, right? So what we can do is we can ignore mass of electron, right? So can I write mass of one carbon atom is equal to 6 into mass of proton plus 6 into mass of neutron, right? Now, can I substitute, because see, mass of proton and mass of neutron is same. Can I take the common? 6 plus 6 into mass of proton, or 6 plus 6 into mass of neutron, right? Which is equal to 12 into mass of proton or 12 into mass of neutron. So far it's clear. Now what I'm going to do is I'm going to substitute this value of mass of proton or neutron, and I will get 12 into 1.67 to 10 raised to minus 24 grams. This is the mass of one carbon atom. Now, if you see this term that is given here, it's very tough to calculate or tough to remember. So what we have done is we have given the name to this much amount as 1 AMU or 1 atomic mass unit. Okay. So now can I write mass of one carbon atom is equal to 12 AMU, right? Where 1 AMU is equal to 1.67 into 10 raised to minus 24 grams, right? This is what this is called as mass of one carbon atom or mass number if we remove the AMU part, if we write just 12. Okay, is it clear so far? Now let's define one AMU in something else. Now one AMU, we know it is 1.67 in 10 to the minus 24 grams, right? Can I write my mass of one carbon atom equals to 12 AMU, right? We have already derived this. Can I substitute this value and find out the value of 1 AMU from here? Can I write this? 1 AMU is equal to 1 by 12 mass of one carbon atom, right? This is what is called as standard. What is the standard? See, 1 AMU is a very less value, right? Every time defining in terms of different atoms would be very difficult. So what we have done, we have defined what the unit of 1 AMU as 1/12 of mass of one carbon atom. Okay. And now we define the mass of each atom of an element in terms of this AMU only. Fine. Is it clear? Are we clear with the mass number? Are we clear with the 1 AMU thing? Are we clear with atomic number? If we are, let's go ahead. Fine. This is so far is given. Fine. Now let's do some questions. Can you do what is the mass of one oxygen atom? Mass of one oxygen atom in mass of one oxygen atom if the number of neutrons is equal to 8. Okay. See, initially when we haven't done any chapter, I'm telling you the mass number, I'm telling you the atomic number, I'm telling you the number of neutrons also, right? Later, you should be knowing for at least these elements which are very common, carbon, oxygen, nitrogen, all of them. Okay. Fine. You can try doing this question. You have a time till you have 30 seconds. Fine. Okay. Yeah. So see, the atomic number of oxygen atom is 8, right? So can I write number of protons is also equal to 8? Number of electrons is also equal to 8. And the given thing is number of neutrons is also equal to 8, right? So from here, can I write mass number or mass of one oxygen atom will be equal to number of protons multiply mass of proton plus number of neutron multiply mass of neutron, right? Which is equal to number of proton plus number of neutron into mass of proton, which is equal to what? Number of proton plus number of neutron into AMU, right? Can I replace the mass of one proton with one AMU, right? So this is a general formula, mass number or mass of one oxygen atom. Okay. Like if we remove AMU from here, it becomes mass number. If you put AMU, it becomes mass of one oxygen atom or mass of any element, basically. So for oxygen, can we write is equal to 8 plus 8, which is 16 AMU. Fine. So what we have derived so far, the formulas that we have learned so far is, let's have a quick revision here. First is atomic number, which is equal to number of protons or number of electrons in neutral atom, right? Then we understood 1 AMU, which is equal to mass of proton equals to mass of neutron which is equal to 1.67 into 10 raised to power minus 24 grams, right? Then mass of an electron is equal to 9.1 into 10 raised to power minus 27 grams, which is equal to 1 by 1837 AMU. Now I can use it as AMU, right? Then what else we studied? The mass of one atom of an element is equal to number of protons plus number of neutrons into AM, right? These are the things that we have started so far. Clear? Now, this is about an atom. What about a molecule? What about a compound, right? For example, can we calculate mass of one oxygen molecule? See, so far what we have done an atom. Now we are going to do molecule. Now in this molecule, we can see there are two oxygen atoms present. So can I do mass of one molecule of O2 is equal to 2 into mass of one atom of O, right? Because see, both are oxygen, oxygen. Whatever the mass of one oxygen is the same as the mass of the other oxygen, right? So I can just multiply it with 2, right? We calculated here, it is 16 AMU for one oxygen atom, right? Here, can I write 2 into 16 AMU, which is equal to 32 AMU. I can do this, right? Now it has become very easy because I know the number of protons, I know the number of neutrons. If I know that, I know the number of mass of one atom of the element. And if I know the molecule formula or the formula of a compound, I can calculate the mass of that molecule or that compound also, right? Now this is for one oxygen atom, oxygen molecule. Let's do it for mass of one CO2 molecule. Okay, this is a question and you guys have 30 seconds. Please try to solve this. Okay. And please, while solving the question, I just want to add, if you like the video, please share it with your friends so that everyone who is in need of it can understand the concept. Okay, make sure you're subscribing to the channel. And if you have any doubt, you can put it in the comment section. Right? Yeah. Okay, let's see how to solve this question. Now, always simplify it. Okay, what is given to us? CO2 molecule. So can I write mass of one molecule of CO2 is equal to mass of one carbon atom multiply number of carbon atoms plus mass of one oxygen atom multiply number of oxygen atom in CO2 molecule, right? I can do that. Now, what is mass of one carbon atom? We did it here. It is 12 AMU, right? I'm not going into the number of protons and number of neutrons. Now we are aware of that step. Okay. So mass of one carbon atom is 12 AMU. Now, what are the number of carbon atoms in CO2? It is 1. So 1 plus mass of one oxygen atom, 16. 16 AMU. And what are the number of oxygen atoms in CO2? 2. So can I write 12 AMU plus 32 AMU, which will give me 44 AMU. Easy? Any doubt? No, right? This is very, very easy. And you will understand why I'm talking about all this. Okay? Later, when we are going to deal with the next topic, here itself in the meeting, you'll understand why I'm talking about all this in detail. Right? Let's do a bit difficult one. Calculate the mass of one molecule of glucose. Now, the formula of glucose is C6H12O6. Fine. I'm telling you the atomic number of carbon is 6, number of neutrons is 6. Atomic number of hydrogen is 1 and number of neutrons is 0. Atomic number of oxygen is 8 and number of neutrons is also 8. Okay. Now you can use this to find out the mass of one molecule of glucose. Fine. You guys have 1 minute to solve this. Let's try. Okay. And then we'll discuss about it. Okay. Did you guys try this question? Okay. Let's see. Okay. Mass of one molecule of glucose. When I write is number of carbon atoms multiply mass of one carbon atom, right? Plus number of hydrogen atoms multiply mass of one hydrogen atom plus number of oxygen atoms multiply mass of one oxygen atom. Okay, can I write this? So here, what is the number of carbon atoms? 6. Mass of one carbon atom is, you should remember now, 12 AMU. Okay. Number of hydrogen atoms, 12. Mass of a hydrogen atom is 1. Why? We can see the atomic number of hydrogen is 1, which means number of proton is equal to 1 and number of neutron is equal to 0. So mass of an hydrogen atom is 1 plus 0, that is 1 AMU. Okay. Plus 6 into 16 AMU, right? Do the calculation. 6 to 72 AMU plus 12 AMU plus 6, 96 AMU. And if you sum it up, it will give you 180 AMU, atomic mass unit. Clear so far? Do you guys have any doubt anywhere? I hope now it should be very clear. And now we are going to move to the topic, which is actually the chapter name, the mole concept. And now you will understand why I'm trying to teach you guys all this. Fine. Now, have you gone to the market to buy a banana? So what do? You go and tell, give me half dozen banana or 1 dozen banana, right? What is this 1 dozen? 1 dozen is a specific quantity, right? Which is 12 units. If you say, get me 1 dozen apple, what it means? 12 apples. Or if someone says, get me half dozen of papaya, means 6 papayas, right? So this is a fixed number and it has been given as a unit, right? Same way, there is a quantity or a unit called as 1 mole, which is equal to 6.022 into 10 raised by 23 entities. Okay? Means if I say 1 mole of pens, it means I have 6.022 into 10 raised by 23 pens. Okay? If I say I have 1 mole of chair, means I have 6.022 into 10 raised to 23 chairs. Okay. This is what 1 mole is. Just like how 1 dozen is equal to 12 units, same way 1 mole is equal to 6.022 into 10 raised to 23 entities. Fine. This 1 mole is also, this number is also called as Avogadro's number. Remember this number, it's very important. We are going to use it very frequently. And it is denoted by capital M, small a. Okay. This is Avogadro's number. Fine. Is it clear so far? Means if I say 1 mole of carbon atom. So can I write, I'm talking about 6.022 into 10 raised by 23 atoms of carbon, right? Same way, if I say 1 mole of O atom means oxygen atom. What will it mean? It will mean 6.022 into 10 raised to 23 atoms of oxygen, right? Now, if I say 1 mole of O2 molecule, see, here the trick is it is entities. If I'm writing atom, then it is 1 mole of atom, means Avogadro's number of atoms. If I'm writing 1 mole of a molecule, it is Avogadro's number, that is 6.022, 10 raised to 23 molecules of O2. Whatever thin is there on the left side, same thing will be there on the right side. Okay, means if I'm talking about number of moles of a molecule, it means I'm talking about the Avogadro's number of that molecule, not the atom. Okay, so now in the same thing here, can I write 2 into 6.022 into 10 raised to 23 number of oxygen atoms? Why 2? Because now we know that one molecule has 2 atoms of oxygen, right? When it has 2 atoms of oxygen, then Avogadro's number of molecules of oxygen will also have 2 into Avogadro's number of oxygen atom, right? So this is how we calculate the number of atoms or number of molecules present in 1 mole of a substance. Clear? Let's find out. Let's do some questions on it. Okay. What is the number of atoms present in 10 moles of H2O? Okay, total number of atoms. Let's see this question, how to do, and then you can do the next question, your own. Fine. Now, total number of atoms. First, let's do one thing. Let's see, we are given with moles of H2O molecule, right? Let's start step by step. So what we understood so far, we have H2O molecule. What we are supposed to calculate? Number of atoms, right? So what can we do? We can do it for one H2O molecule first. So one H2O molecule has one hydrogen atom, right? Plus 2 oxygen atom. Sorry. One H2O molecule has 2 hydrogen atoms plus 1 oxygen atom, right? So in total, we have 3 atoms. Now, one molecule has 3 atoms. Then one mole will have how many atoms? I can just multiply these 3 atoms into Avogadro's number, right? Which is 3 into 6.022 into 10 raised to 23 atoms. Fine. Now this is present in 1 mole. What are we given with? We are given with 10 moles. So 10 moles will have 3 into 10 into 6.022 into 10 raised to 23 atoms, right? If we solve this, it will become 18.066 into 10 raised to 24 atoms, or 1.8066 into 10 raised to 25 atoms, right? Here we have been asked with the total number of atoms, not what are hydrogen atoms, what are oxygen atoms, what is the total number of atoms. Okay, let's do one more question. This time you guys will try. Okay, what is the number of hydrogen atoms present in 0.25 moles of C12H22O11 molecule? Okay, similar type of question. You have to find out, in this case, instead of finding out the total number of atoms, you have to find out the hydrogen atoms. Okay, try doing this question. You have 1 minute's time. Fine, let's see how to solve this question. Now, what we are given with C12H22O11 molecule. Fine. We have to find the number of hydrogen atoms. In one molecule, how many hydrogen atoms are present? 22, right? So, number of hydrogen atoms in one molecule of C12H22O11 is 22 atoms, right? How many will be there in 1 mole? 22 into 6.022 into 10 raised to power 23 atoms of hydrogen, right? Now, how many moles are given? 0.25. So, in 0.25, how many will be there? 0.25 into 22 into 6.022, 10 raised to power 23 atoms of hydrogen. You can do your calculation, okay? This is how we are supposed to solve the question. I hope this is clear now. Let's go to our next topic, which is quite important. Now we have calculated the number of uh, molecules or atoms present in a mole. Let's see what would be the mass of these atom or these molecules in a mole. Okay. We know mass of one carbon atom is equal to 12 AMU, right? Now, mass of 10 carbon atoms will be equal to 12 into 10 AMU, right? Mass of 6.022 into 10 raised to 23 carbon atoms will be equal to what? 12 into 6.022 into 10 raised to 23 AMU, right? Can I write this 6.022 into 10 raised to 23 as 1 mole? So can I replace it as mass of 1 mole of carbon atoms is equal to 12 into 6.022 into 10 raised to 23 AMU, right? Now, if I put the value of 1 AMU, what is the value of 1 AMU? 1 AMU is equal to 1.67 into 10 raised to power minus 24 grams. If I substitute the value of 1 AMU, let's see what comes out. 6.022 into 10 raised to power 23 into 1.67 into 10 raised to power minus 24 grams, right? Now, this mathematical expression, if you multiply, it comes as 1. So, the mass of 1 mole of carbon atoms is equal to 12 grams, right? But 12 was the mass of 1 carbon atom, though in terms of AMU, but it was, right? So, can I write mass of 1 mole of atoms of an element is equal to mass of 1 atom of the element, but it in grams. Likewise, for example, we did the mass of one oxygen atom. How much it was? 16 AMU. So mass of 1 mole of oxygen atoms, what it will be? 16 grams. Right? Same way, mass of 1 mole of oxygen molecule. Now what we can do? Again multiply with 2, right? 2 into 16, that is 32 grams. And if we see, we also did this question and we got 32 AMU, right? Here it is 32 grams. So this proves, I can write down this formula, mass of 1 mole of substance or entities is equal to mass of 1 atom or 1 mole molecule of substance in grams. Okay. So here, if on this side it is atom, then this side also it will be atom. If this side it is molecule, this side also will be molecule. It depends. Now, if this side is molecule and that side is atom, you have to multiply it with the number of atoms. Okay. So now, for example, 1 mole of C6H12O6 What will be the mass? The mass will be 180 grams. This mass of one molecule, 1 mole of a substance is also called as molar mass or gram molecular mass. Means GMM. Molecular mass in grams. Okay. This is very important that 1 mole of a substance is equal to its molecular mass or atomic mass in grams. Fine. So now we know two terminologies. Mole, right? 1 mole is equal to molar mass. Also equal to 6.022 into 10 raised to 23 entities. Now, this is a very important formula, I would say. Why? Because see, if we are given with the mass, right, we can calculate the number of moles. I'll come to the questions, don't worry. If we calculate the moles, we can calculate the number of entities also, right? For example, now we have given a question. Calculate the number of moles of glucose present in 18 gram of it. Now we are given with what? Glucose, which is C6H12O6, right? And how many grams are given? Grams given is 18 gram, right? Now what we have to calculate? We have to calculate number of moles. Now simple, 1 mole of glucose molecule. What is the mass? 180, 180 gram, right? Now how many moles are present in 1 gram of glucose? 1 by 180 moles, right? What we are given with 18 gram. In 18 gram of glucose, how many will be present? 180 multiply 18 moles, which is equal to 1 by 10, which is equal to 0.1 moles. Okay. So if I do this question directly, can I write down number of moles is equal to grams given, which is given to us in the question, divided by molar mass, right? Let's solve this question, which we did just now. What is the gram given? 18 grams, right? What is the molar mass? We are given with the molar mass of 180 grams. Directly we got 0.1 moles. 180 gram per mole. Okay. So from there we got 0.1 moles. Fine. Now this is clear, and this part, number of molecules and number of atoms is clear. This formula should be very much clear. Why? Easy. Let me modify this formula. Number of moles is equal to gram given divided by molar mass, right? Number of moles can also be calculated. Number of atoms, or instead of atoms, let me write down number of entities divided by Avogadro's number of entities. We can do so, right? Why we can do so? See, if we are given with the gram, we divide it with the molar mass, we'll get the number of moles. Same way, if we are given with the entities and we divide with the Avogadro number of entities, both the ways will get number of moles. Is it clear? This is very important formula. Try doing questions on this formula. We'll do the questions on this formula in the next class, as it will give us a very nice revision and we can continue as well, right? But this is really important formula. Okay. Let's have a very quick revision of the formulas we did. So here we had a revision. Yeah, this one, right? After this, what we have studied? We have studied 1 mole is equal to 6.022 into 10 raised to 23 entities, right? What else we studied? 1 mole is also equal to molar mass. Mass of 1 mole also equal to molecular mass in grams, right? And this formula. Then number of moles equals to gram given by molar mass. Also number of moles equal to number of entities divided by 6.022 into 10 raised to 23 entities. When I'm writing entities again and again, see if it's atom above, it should be atom below. If it's molecule above, it should be molecule below. If there is a change, convert either the molecules to the atom or atoms to the molecule. Okay. These are the important formulas that you should know so that we can proceed further in the next class. I hope the video was nice. You were able to understand everything. If not, please put it in the comment section so that I can understand and make the better videos. Okay. Stay tuned for the next video. Thank you so much, guys. Bye-bye.